today we've got this kind of fun buzzword here, using identity to evolve application security. Kind of to sum it up, really what I want to talk about is beyond authentication, beyond authorization when it comes to applications and users, figuring out a way to establish identity, talk about places where how that identity can be used, and then kind of in talking about places of other projects and other teams out there that are trying to solve a similar problem. Who am I? So my name's Kevin Paige, as introduced. I'm the CISO at MuleSoft. So MuleSoft is an interesting company if you haven't heard of it. I was hired there as the first security person. So over the 2 years, kind of started with the compliance program, started with the security DevOps programs. We built that and built the application security program. MuleSoft went public this year, so it's fun, really fast, high moving company, and things are going really well there. Myself, I always like to kind of say that I'm a defender, mainly because a lot of times at OWASP there's a lot of pen test people and application security focused people. Of course, the best defense is a good offense, is kind of how the saying goes. But being a defender, I think, gives you a little bit of a different view. You're using offensive tools in a kind of a continuous testing manner to make sure that you're testing your area of responsibility, your network, your applications, your systems, and working on that defense in depth model. Continuous learner. I like to say I'm a continuous learner because kind of as my career has evolved. Yeah, so MuleSoft is located in headquarters is in San Francisco. So I'm here from San Francisco. Headquarters in San Francisco. I'm global company. We've got offices in Buenos Aires, London, Australia. So it's a really fast growing company. I guess quick interesting fact, like when I got there was 2 years ago, there was about employee number 400, just under 400, and we just hired employee number 1,300. So super fast growing company, which from a security front, especially kind of as you're growing the security programs and trying to build a security culture in a company, is really interesting. A lot of interesting challenges. I'll save those for another talk. but there's a lot of fun stuff to talk about there. And kind of as my career's gone from a continuous learner perspective, it's just I spent the first part of my career working in the federal government, working at Department of Defense agencies, constantly working on new innovative ways to build infrastructure security, build application security, and continue down the security track, and then moved out of the government sector and worked for a small little itty bitty startup, building out their operations security from the ground up again, a little company called X Matters. Then went to Salesforce, big behemoth of a SaaS entity, and worked security there, and then over to MuleSoft to kind of start security there. And MuleSoft's kind of interesting for this conversation as well, because it drives a lot of my thinking around APIs and integrations. So that's what MuleSoft does. So MuleSoft is a company that helps lots of other companies expose APIs, integrate APIs, especially from cloud to on-premise, from on-premise to on-premise, whether you're trying to integrate SAP with Salesforce or any type of integration that you want to do. So thinking about identity and bringing identity early into the life cycle of an application, I think becomes very important. It's always important to say, as I talked about the employer, it's always important to talk about that the opinions expressed in this presentation are those of mine, not of my employer. So a lot of them are factual and they're grounded on great information. And I think that even if you don't agree, I think that it's going to definitely make you think. And I think that's the most important thing with a lot of these talks. So good question. Why must we evolve our security practices. I mean, there's lots of reasons. There's a million of them, right? There's a million of them that you can think of. You know, this is a great reason right here. A good offense, right? So defense, you know, like I said earlier, requires a good offense, and having new innovative security practices to keep people doing the right thing is super important. But really, foundationally, a lot of our security practices are very old. They're very ancient. They've started a long time ago. I mean, a quick kind of description of that is just the model of defense in depth. Everybody talks about defense in depth. Everybody talks about layers. It's the best way to do security, right? But defense, obviously, just by the name of it, you're not designed to win. You're designed to lose. You know, I mean, a good kind of correlation of this is that, you know, if you work in your companies or you work with a lot of pen testers, you know, the pen testers are always happy. You know, they're always you know, having a great time, walking around and giving high fives because they got that O-day, they got the win, right? They found that one exploit. Where a lot of times your defenders, you know, not so happy because they're on call, you know, got woken up, another security incident, another ransomware attack. You know, you never win, right? On the defense side, you're always getting beat up. On the offensive side, you know, you only have to do one thing to win. From a I guess personality perspective, or how that kind of weighs on somebody over time is interesting. And if you've never thought about it before, I guess go back to your companies or talk to people that have been on the defense side and compared to the offense side, and take a look at the kind of how the personalities are generally a little bit different. And I think it kind of boils down to, you know, somebody can get really easy wins or wins. Might be hard to pen test and find that O-day or find that vulnerability. But you only have to find one. Where you're a defender, you have to defend against all of the things all of the time. So defense not being designed to win, and obviously it's always been said in the past that, you know, if you're a defender, especially of an enterprise-based company, you know, offense is not something that you want to participate in because of legal ramifications, liability, and things of that nature. And how can you, in theory, have a good defense without a good offense? So you're designed to lose. Another big problem: traditional perimeters are disappearing. So with no perimeters, how do you handle that? At my company, we don't have a server, right? We use SaaS services for everything. For HR, we use Workday, Salesforce for our sales team, NetSuite for our payments team. We use SaaS services for everything. We use Google, we use AWS for infrastructure mechanisms, and all of those things are all interconnected. So the fact that there's no perimeters, we can't put everything in a nice little box behind 5 firewalls anymore. It's not practical, and we have to think about that as we think about identity and we think about the future. From an API perspective, microservices perspective, things aren't servers anymore, right? There's containers, there's microservices, there's serverless. The scale of these things is huge, right? We don't have a bunch, 5 or 6 servers in a rack anymore that we're worried about securing. Now we've got containers everywhere. We have APIs everywhere. I mean, most of the big common apps out there, look at the Uber app, right? Uber, especially in the beginning, was almost not much to it except for APIs, right? For everything that it was doing, it was calling another service, wherever that service may existed. You know, Google for a lot of its mapping capabilities. It was using other SaaS vendors for billing. A lot of that stuff has changed over time. But the one thing that hasn't changed over time with Uber or a lot of the companies is the ability to have an API first design. But everything has an API these days, right? So Facebook, right? Facebook's has a great API. A lot of people are using the API, not even logging in. A lot of people are using AWS. I myself haven't logged into the console forever, using things like Terraform and using mechanisms that the Bodo suite of libraries to make API calls. It's much easier to make API calls than it is to log into the console. It can be faster, can be more efficient, but from my laptop, wherever I'm at, those Google or those Amazon APIs, that opens up a new way of having to think about how to protect this surface area that has no borders. And the breaches are growing, right? This is just a common sense. If nobody's ever gone to this visual, it's a great visual. Each one of the circles is kind of based on size and magnitude. But if you scroll all the way down, and just kind of watch up, I mean, it's a great visual representation to see that. I think it goes down to like 2006. And 2006 it shows like 6 little dots, or maybe 4 little dots. Then you start scrolling up 2007, 2008, 2009, 2010, till you get to 2017, and there's like no white screen anymore. Just lots of big breaches, right? They're continuing to grow, right? There's too many reasons to discuss all of the reasons why they're growing, but they are. Lots more software out there. The reasons that we mentioned before. Lots of vulnerabilities. Spending time and effort, energy to make sure that those things are patched, that you have the right security mechanisms in front of it, and you're doing security the right way. So another problem that needs to be thought of. The other problem that kind of goes hand in hand with that is that technology, these APIs, they're being used for more and more very, very critical functions. Whether it's medical devices, whether it's cars, pretty soon autonomous cars. All of these things have APIs on them. They all have some kind of mechanism for talking to cloud services, and they are all doing things they're running devices and programs and mechanisms of things that could hurt somebody, that could kill somebody, or that could cause a major issue. Not only are they doing that, but we're moving faster, right? Teslas now can do over-the-air updates, right? So there's your autonomous car you're driving in, and you're getting updates in it, and if you can get an update from Tesla, I'm sure you can get an update from some hacker, some guy that wants to do something bad, or some curious guy who's just looking around and accidentally click something to cause a problem. So how do you help think about that and solve for that? Hey, we talked a little bit about a couple minutes ago. We talked a little bit about the security approaches being outdated. Defense in depth. It's a common term throughout the security industry. It's been around forever. We're talking about a guy here, Edward Ludwig, who used the term defense in depth, to describe strategies in 3rd and 4th AD. Even the military, a lot of these principles are based on the military. You read one of the Army field manuals, and they're talking about security operations. They're talking about how to segment and how to box enemies in, all based on a defense in depth approach, right? They use different terms, but very similar. They're using listening posts and observation posts, just like we would say, hey, you put an IDS here. They're using firewalls, and they're using capabilities to, instead of tracking and monitoring all data that's coming in, they're tracking and monitoring all people that are coming in. But the fundamental approaches are kind of based on physical security, based on military mentalities, not really based on software development, not really based on user access. And with these kind of thoughts, they need to make us, we need to kind of, I guess, rethink that approach. That approach is great at the foundation, but times are changing, times are evolving. We can't keep using the same term, defense in depth, that we've been using for a long time. I think I started using that term when I worked for the Department of Defense, in the late 90s. So late 90s, we've been using the same term in computer security. I think it's common to think that effective security can't just be bolted on, right? Over the years, with our defense in depth model, almost encourages us to bolt security on, right? Because we're trying to build layers, we're trying to slow the attack down, divert the attack. We're trying to use different approaches in order to make in order to bolt these security mechanisms on without kind of focusing on the application, right? With secure software development life cycles, we're saying, hey, let's bring that earlier in the life cycle. Let's do threat modeling. Let's talk about different ways and methods to be able to handle building security in. But let's think about it holistically. A lot of new terms are really great, like security by design. So to make sure that as you're designing your application, as you're designing your deployment methods and methodologies, let's think about ensuring that that's done in a secure way. I think one of the great things from a security perspective, looking at the DevOps movement, is really one of that fundamental thought process of understanding your pipeline, understanding how you're gonna design, continually integrate, and then how you're gonna deploy. And once you kind of have that defined, once you have it translated into code, then it's very easy to do validations, to run tests on it, to make sure that things are built the way they're supposed to, and the way to start building security into the code, and doing validations based on your code to make sure that the security mechanisms are built in. But I think it's kind of fundamental to thinking about authentication, authorization, or just identity in general, whether it's people, application, whatever it may be, that fundamentally it's important to start thinking about always building security in. Of course, I'm sure I'm preaching to the choir with security people here, but it's really not. Being in San Francisco especially, I've worked for a lot of startups. I work with a lot of startups. And the more and more security people are thinking about security. They're thinking about it only because, not that they're thinking about it, it's easy, right? Thanks to Amazon and Google, giving developer services, like a key management system that's an API. Like, heck, I'll use it because I got an API in front of it. Or other mechanisms like encryption. I can just click a button on encryption if I'm using, Amazon RDS. So these vendors are starting to make security easy. So security is I think is getting better and coming more into the design phase because of these infrastructure as a service or platforms as a service vendors. They're making it easy, and if you make it easy, of course, people are more likely to use it. And I guess the good with the bad, right? We talked about the breaches, right? Everybody knows about the breaches. Some people take them seriously. They get scared of them. They want to make sure that they try to do the things correctly. Whether it's making sure they're hashing passwords, with a strong algorithm, learning more about hashing and figuring out how to, separate your items. I think it's getting better, but it's definitely not a primary focus, and it's definitely not something that a lot of companies are thinking about. Which kind of I guess rolls into the problem, and that is that from a security perspective, when you're thinking about these problems, you really need to think about trust. Trust needs to be integral into everything you're doing, from end to end. And without kind of a solid trust model, and that trust model needs to be based on some kind of identity, without that ability to trust your application, and trust the communication mechanisms that go into that, then like how can you ever really know what's happening? How do you ever really know who's accessing your service? How do you ever really know who's doing what? Especially in the day of APIs, when most of the time it's not a person, it's a machine. It's an application talking to an application. It's not just a user logging into a website. This has been something that that's been talked about for a long time in the security world and in the application security world. I remember in the early 2000s working with service-oriented architectures. It's where it kind of really hit home with us. We're like, hey, there's not really people accessing these things. We're exposing these, back then, XML, WSDL-based services. We've got XML service, we've got WSDLs talking to WSDLs, we've got XML talking to XML. How do we know that the right thing should be talking to it? And we're like, that's a good question. Like, how do you solve that? We tried solving it with Xacaml back then, if you remember that, with policy decision points and policy execution points, and trying to make security easier from application to application communications, trying to do things with attribute-based access control. But those things still required a lot of ways to build trust, and that trust still wasn't there. And that was the problem. Probably one of the reasons why the whole kind of SOA, to a lot of people in the world anyways, just mention the word SOA, people cringe up like, yeah, that was ugly. Because it was. But building that layer of trust in is important and critical, especially from an identity perspective. The big question is just how to do it, and it doesn't really make the most sense. I think it does, and I think that kind of fundamentally as we build applications, we need to think about trust, and we need to think about how do we establish these levels of trust model. So from a security perspective, just kind of sum up all of those kind of problems that I was talking about into kind of one slide. There's lots of reasons and there's lots of things out there that are problems. They're not really problems. It's just evolution. Software and technology is moving very fast. It's obvious out there. And at that rate of change of technology, security needs to become a first-class citizen. How does security become a first-class citizen? Well, security is kind of a generic term. What's security? I might as well just say cloud, right? We need to talk about specific points and specific aspects of security that we can focus and target on. And one of the areas that I think is kind of very important is identity. And I think that as you kind of look at history, with anything, you kind of look at like IDs, right? Whether it's a driver's license or a human identification. The idea of IDing a person was important, right? For lots of different reasons. It took a long time to get human IDs there. But after human IDs, we definitely understood that the services that humans were using, especially big important things, were important as well. A quick, easy example of that is VINs. So vehicle identification numbers on a car. According to Wikipedia, in 1954, some car manufacturers started using VINs, and that's great, and they, the developers or the car manufacturers, they saw a need to create specific identities for cars, right? Probably based on safety reasons, other reasons probably just for tracking, but security was definitely one of those reasons. The manufacturers saw it, and it wasn't until 30 years later that regulations or regulatory bodies saw that need was also important, and the ability to tie things to to tie that service, that automobile service, to a unique ID number, and then also tie that with a unique person number. To tie those things together became very important for tracking, for safety, and just for general purpose. That example is really talking about a big vehicle with a bolted-on VIN, but I think that the idea of it is the same, right? It's old technology, old ways to do things, but I think history kind of is showing us, kind of teaching us a lesson that the services that we use, if we want them to be safe, if we want kind of good, interesting ways to use them, if we want auditability, if we want traceability, if we want the ability to do interesting things with them, the ability to identify them becomes very important. And the interesting thing with a VIN is that not only does it track and trace the car, but it also points to the components and the things that are in the car. A lot of those things have identifications as well. Those identifications can tie to the VIN, and that can help with safety recalls and can help with understanding how things work and where it goes. So I think from an identity perspective, there's lots of other use cases, but I thought this one was kind of the most glaring and most kind of easy to talk to, because it's one that everybody's used to, for most people, if you got a car anyways, and you have insurance. It's one that people know about and kind of is kind of close to their hearts. So as I was thinking about identity, thinking about authentication, thinking about authorization, thinking about security by design, I was like, hey, whoa, let me think. Security by design, identity. You need to think about identity early in the life cycle of anything, of an application, of whatever it may be. Hey, identity by design. So I don't know if I Googled it. I didn't see anybody else out there with it, so it might be a new term. I don't know. So I kind of threw a definition there of what I think kind of identity by design is. I mean, it might be. Basically a concept of designing cryptographically verifiable trust chain, which ensures proper identification. That's kind of the high level of it, and kind of what I think that an identity by design might look like in general from an application ecosystem. Sorry. From an application ecosystem. And from an application ecosystem, it really, in order to create this trust model, needs to include everything that has to do with an application. When we say everything, I mean everything. So the application, depending on how it's running or what it's running on, I guess we'll start from the ground up, is that there's a server someplace, a physical server someplace that's running this thing. That server needs to be trusted somehow. And then in order to trust that server, you're also going to probably install a virtual server on there. It's a model. Maybe you have one, maybe you don't have one. Maybe you're using Docker, maybe you're using some containerization strategy. That container should have some kind of identifiable model. And then inside that container or on that server or wherever it may be, there's going to be some kind of application. That application needs an identity as well. We've seen similar models, I think. I think that from an identity by design perspective, from a physical server perspective, Active Directory does kind of this, right? So you can, register. It's using Kerberos under the hoods, and you're registering your server, you're registering your user, stored in LDAP, and you've established an identity, with your host name, with your Kerberos token, and your identity is being established through that Kerberos method and LDAP method to give you user identity and server identity, and that's great. Again, when you're behind a firewall, and all your users exist and all your servers exist, in one particular data center. and you can verify that server. Might even be able to verify that virtual server using Active Directory. If you're behind your firewall. But the problems that I talked about earlier mean that you're not behind a firewall anymore, right? You might be, some things might be, but everything's not going to be. Every company, every developer, it's too easy to use things like AWS. It's too easy to use things like Heroku from a platform as a service perspective. It's too easy to use these things. People are going to use them, and not only are they gonna, they are. They're rampant, right? And great stuff. There's ways to secure them, ways to handle them, but when these things are communicating, from a design perspective, I think we need to really think about how we're going to establish that design. How are we going to tie these things together? How are we going to establish this trust chain and this trust model? One interesting model that we've been playing with is establishing a trust tree. So the interesting thing with a trust tree, and this is kind of a Merkle tree-based model from a blockchain perspective. With this Merkle method, you can establish lots of different levels of trust, right? The common way that people are doing this today, I'll talk about a couple of them in a little bit, is using X509 certificates, right? X509 certificates have hashes on them. You can take those hashes, you can create a hash table, right? And once you have that hash table, that's great, but now you want to do something more with it, right? Like, how can you do stuff with it? How can you do things with it? Well, one of the things that you can do is have a mechanism that provides different layers of trust, right? So if you guys don't know what a Merkle tree is, it's a hierarchical-based hash tree, right? That's basically what it is. And at some place, you can establish your main mechanism of trust. Under that levels of trust, you can create different levels. Once you've created this tree and created this cryptographical verifiable method of establishing things who say who they are, you use X509 certificates to establish identity. I think you've started down the identity path. You've started down the way of taking a look at, hey, I'm identifying everything with an X509 cert, or with some other token-based mechanism that can be cryptographically verifiable. There's some blockchain things out there that people are doing in a very similar way that aren't using X509. But X509's, regular certificates are common. People know about them. They've been using them for a long time. They're used to them. And taking this model, taking these hashes, extending X509 and establishing this trust model using X509s on this with the hashes helps create an identity, because you're using the SSL certs or TLS certs for identity, and it's also helping you create that tree, create that model, establishing trust between things. And I think that this thinking, creating the trust model and creating these trees, helps get you to the point that you've created these unique identities, and then you can start doing other things with these identities, like access control and other mechanisms, using mutual TLS and using other mechanisms that allow you to clearly identify an entity. That entity could be whatever you want it to be. It could be a server, could be a container, could be an application. And you have another server, an application. Each one of those things could have different levels of trust or have different trees. And then ideally you can associate that with access control to be able to make those things talk. So that trust tree I think is super important. A little ahead of myself. But from a proof of possession, I think proof of possession is kind of the next important aspect of this, because you have identity, right? So let's say we're using X509 certs. Let's say you're using mutual TLS. That's great, right? So I've got client server-based certificates. Only these clients can talk to these clients. Only these clients can talk to these servers. That's great. But now I want some way that's going to prove that only the right things have it. And then maybe I want a mechanism that also reassociates, and revalidates it on a given time. So part of that, I think, is in a registration process. And not just a registration process, probably a multi-factor process. Some kind of two-factor mechanism as part of that registration process that associates. You've gone through the process, you've associated the client cert, and I want to associate the client cert with my trust tree. And you verified it and hit your button, or conducted a registration process. Could be an offline registration process that establishes that this item is supposed to have this particular certificate, and you've established that level of trust, and you verified it, and that certificate, that client cert or token or whatever it may be, is there for verifiable proof that you can use. It's also cryptographically verifiable to make sure that the right things are where they're supposed to be. The interesting thing, the registration process, of course, big fan of multi-factor. Who isn't? A great way of using a device, using some kind of secondary mechanism to establish that verification. I think becomes important, and I think that it's a great way to do it. Especially the proof of possession. I think that becomes very important because in establishing identity. Because just like otherwise you fall into the same, if you're going to use certs, you fall into the same problems that everybody does using PKI now, and that's that, it's a pain to get a cert, it's a pain to deploy a cert to an application or to a server, or to a Java key store, or to wherever you're putting these certs. And then how do I rotate them? How do I expire them? Oh, people just bypass them. Oh, let's just use self-signed certs everywhere, not paying attention to certs, but let's just make sure that we're using encryption between two services. These are kind of the common things that I hear. So if you're going to use X509 certs, let's complement it with another access control mechanism that's doing real-time kind of, well, not real-time, but doing verifications. At least it happened once, and then you have the mechanism to revalidate your trust train whenever you need to. So, the identity by design. I think that it's now you've got your identity. We'll call it an X509 cert. You've got your model, your trust tree, and you've got verifiable proof that your things have been put where they're supposed to be. And you've got an audit trail and a mechanism in which to re-verify those things. I think that puts you on a good path for other future looking ways to establish connectivity between things, to not allow connectivity between things. It'd be really great, let's say you've got a backend API, everybody registered with a certificate against that API, and if you haven't registered against it, then you can't hit that API. So from a consumer perspective or from a business-to-business perspective, it seems like a really good way to do it. If somebody wants to attack you, well, guess what? You know who's attacking you because they had to register and they have a certificate on their device or inside their application, and then you can just turn it off. You can no longer access my API. I think that level of identity provides a lot of power in that particular use case, and a lot of other use cases. And I think some of the interesting ways that we were talking about doing identity by design is it goes right along with the way that we kind of started working down this security path. As I kind of said in the beginning, right? We started with kind of security by design by starting to think about doing security earlier on in the software development lifecycle, earlier on in the process of building an application. The zero trust model, right? The zero trust model is a great thing. Google done some great stuff with it. There's a lot of people out there talking about this way of to do zero trust. Lots of terms out there for it in the security world. I think last year, microsegmentation was the big buzzword, or was it 2 years ago? I don't know. But microsegmentation was the big thing, right? Microsegmentation is saying the same thing, right? Zero trust model. I only want to segment, my web server to talk to my app server. Only my app server can talk to my database server. I've got IP tables that I'm handling outside of it. That's only allowing these things to talk together. And that's creating these segments, which is interesting, right? So then you can kind of use that model to manage things, that exist not just inside a data center anymore, but you're still kind of stuck because you're still only talking about servers because you're only talking about IP tables, right? Or you're talking about whatever little agent that they installed on your box to be able to do those things. But I think that it's a great start, and I think it's probably one of the starts to this verifiable method. And I think some of the stuff that Google's done and a bunch of other vendors have done to get to this zero trust method, are great. A lot of them are based on identity. They call it authentication, right? But it is that authentication is tied to and tracked with some kind of identity source. That identity is what helps them, log into these servers, from wherever without having to worry about firewalls. So BeyondCorp was Google's zero trust model, and BeyondCorp was great. The principles there, fantastic principles, right? Totally based on a zero trust model, right? So basically, connecting from a particular network doesn't determine what services you have access to, right? So there's no firewall, there's no VPN connection. You're not VPNing into something and getting associated with what you can log into. Access to services is based on very similar things that I talked about, although it's more kind of focused on devices than it is on application communication. But the idea is fantastic. And the stuff that they built, and a lot of people and they've released kind of publicly, and there's other things spinning off from it, are great. If you guys haven't read about BeyondCorp or taken a look at some of the stuff they have out there, I totally recommend it. Having access to all services authenticated, authorized, encrypted, that's fantastic. Can't do any of that stuff without an identity. So the fact that they're not talking about identities was kind of the thing that always that was like BeyondCorp. Like the things you're doing are awesome, but you're not really talking about identity. You're just talking about how you authenticate and authorize everything. And by everything, it's really server and laptops or desktops or whatever it may be. But the other thing that's kind of come out, and I don't know if you guys have seen Spiffy. So Spiffy is kind of was started by a bunch of guys in the Bay Area, and really kind of the secure production identity framework. So it's one of the first kind of true identity frameworks that I've seen out there. It's very new, so they don't have anything real yet, but it's really kind of along the lines of what I've been talking about and things that I've been trying to push internally by sticking IDs on everything. Spiffy really came about because of Kubernetes, right? So Kubernetes, containerization, we've got all these containers, we've got all these Kubernetes schedulers, we've got all these pods, we've got all these schedulers all over the place. People are just spinning up containers, and people are dropping applications everywhere, and we don't know who's doing it, we don't know how they're doing it, we don't know if they should be there. How do we solve that? How do we figure out how to make that better? And that's what Spiffy's out to do. So if you're interested in identity and you're interested in kind of in those methods, Spiffy's a great group to get involved with. They're very new. There's not a whole lot out there around Spiffy yet. There's a little project called Istio. If you've heard of Istio, so Istio is another thing that's kind of used from Kubernetes. I think it was I think Lyft and IBM and a couple other big players kind of tried making this mechanism to make security and kind of layered networking inside Kubernetes and containerization easier. And with the idea of sidecars and the idea in Kubernetes and the idea of the ability to handle authentication in front of the container, they trying to go down the Spiffy route. Again, it's not kind of cryptographically verifiable, and it's got a lot of problems. But it's young, but they're on a great path. The kind of the third and last company who I think is interesting is this other company called Beamy.io. Little tiny startup, but very, very interesting if you want to take a look at this X509 method. So they've started down the X509 method, and they're kind of working towards kind of using PKI and using blockchain in order to establish identity. And then once you've established that identity, they've created a couple other interesting things that allow you to automatically connect, from server to server, with those client-based certificates on the machine. So Beamy's pretty interesting. Again, they're not necessarily calling it identity, but they are doing identity because they're using X509 certs. They're figuring out an access control methods that allow two things to talk to each other, kind of using mutual TLS. They're going down that path. They're fully open source, so their stuff's pretty cool. But it is kind of a small startup. Stuff's kind of rough around the edges, right? But it's pretty cool, and it is kind of a good step towards identity. So anybody that's kind of trying to push the envelope on identity, especially at the application space, I think is great and going to help move security and application security forward. And that's it. So that sums up identity, applications,